June 30, 1908. Early morning. The Siberian taiga is still silent, but in a few seconds, an explosion will occur here that still gives scientists no peace. Peasant Semyonov is eating breakfast by the porch of his house in the trading settlement of Vanovada. It is about 65 kilometers south of the future epicenter. He is looking north, and suddenly he sees something impossible. The sky seems to split in two. Fire flares above the forest, bright, enormous, inhuman, serious. Later, Semyonov recalled that in that moment he felt so hot as if his shirt had caught fire. Then came the udar, powerful, sharp. It knocked the man off his feet. And this was dozens of kilometers from the center of the explosion. Now, imagine what was happening where the blow struck with full force. In a single instant, about 80 million trees were felled. The forest was flattened across thousands of square kilometers. This is comparable to the territory of a huge modern city. The blast waves circled the earth twice. Instruments in London, Jakarta, and Washington recorded it. Seismographs across Eurasia registered a shock equivalent to about magnitude 5. And yet, the picture looked almost like a mockery of common sense. No crater, no large fragments, not a single obvious piece of the body that caused such a catastrophe. More than a century has passed, and there is still no final answer. One of the first mysteries of the Tunguska explosion sounds almost paradoxical.
Why was the largest aerial destruction in recorded history barely studied for almost 20 years? The explosion occurred in 1908, and the first full scientific expedition reached the site only in 1927. The reason was not indifference and not bureaucracy. The problem lay in the geography itself. The Podkamenia Tunguska region was then almost cut off from the rest of the world. Hundreds of kilometers of taiga, swamps, and rivers stretched to the nearest large settlements. There were no roads. The railway ended very far away. Beyond that began the real Siberia. Slow, harsh, almost impassable. It took Leonid Kulik, the man who first took this mystery seriously, months just to reach the scene. First by train, then by horse, then by reindeer sled, then on foot through forest, bog, and river fords. It was not just an expedition. It was an advance into a blank spot on the map. But the most surprising thing is something else. They knew about the explosion almost immediately. As early as July 1908, Russian newspapers were writing about a strange event in Siberia. Seismic stations detected tremors. Barographs in Europe showed a sharp jump in pressure. Scientists saw the anomaly, but they did not understand its source. No one then connected these data with the distant Siberian taiga. And this is where the especially strange part of the story begins. Even eyewitnesses on the spot had no language to describe what they had seen.
The owners of 2 gold mines called each other on the telephone that morning. Each thought the other was illegally blasting rock. For them, that was the only familiar explanation. Human experience simply did not contain an appropriate frame for an event of such scale. The physicist who connected the atmospheric and seismic observations with Tunguska did so only in 1930, after Kulik's reports had already been published. That is, for almost 2 decades, the world saw the traces of the catastrophe, but did not assemble them into a single picture. When Kulik received funding in 1921 and reached the surrounding area, he still could not get to the center. The taiga stopped him. The swamps would not let him through. Only 6 years later, with Evenki guides and reindeer sleds, did the expedition reach its goal.
The Evenki were reluctant to go there. For them, the place was cursed. According to local beliefs, the god of thunder had punished people for their strife. No one was supposed to enter there. Some guides refused to go farther. And that matters too. For the local people, Tunguska was not a scientific problem. It was a place of fear. By the way, if details like these interest you, subscribe to the channel. Here we examine not only the event itself, but everything hidden around it. In April 1927, Kulik's expedition climbed the ridge of a hill, and before them opened a view that for decades afterward was retold in almost the same words: confusion, shock, disbelief.
As far as the eye could see, the forest lay on the ground. Millions of trees had been broken by one single blow. All the trunks pointed away from the center. It formed a gigantic radial pattern, as if someone had laid a monstrous wheel on the ground, with spokes kilometers long. The forest had been scorched, blackened. In places it had turned into a dead field of timber. But at the very center, everything looked different. There the trees were still standing, not felled, not torn out by the roots. They stuck up as bare trunks, without branches, without bark, almost without life. Kulik called this place the Forest of Telegraph Poles. The name stuck, and to this day it remains one of the most accurate descriptions of what was seen. Later, physicists proposed an explanation. If the explosion occurred not on impact with the ground, but in the air, directly above that point, then at the center the shock wave would have traveled almost vertically downward. It would have stripped away the crown, broken off the branches and bark, but not necessarily knocked down the trunks. Farther out, along the edges of the affected zone, the wave would already have been moving at an angle, and there it uprooted the trees. This explained the shape of the destruction, but it did not answer the main question: where was the crater? Kulik had gone there precisely to find it. He expected to see a gigantic impact crater from a fallen meteorite. Instead, he found marshy pits and lakes.
One such depression was long considered by researchers to be a possible impact site. It was called the Suslov crater. Expeditions spent time and effort draining it, but when the bottom was finally examined, they found an old tree stump there. That meant one simple thing: the pit had existed before the explosion. Serious. No crater, no large fragments, no sign of an ordinary meteorite fall. And yet the power of the event was estimated at roughly tens of megatons of TNT equivalent. Most often the range given is from 10 to 15 megatons. For comparison, that is many times more powerful than the bomb dropped on Hiroshima. In other words, something colossal exploded over the taiga and almost vanished without a trace. There is another mystery as well. The explosion occurred in the morning in Siberia, and by the very next night Europe saw a strange sky. For several nights in a row, an unusual glow hung over Russia, Europe, and part of Central Asia. People called them silvery nights or white nights. But these were not the ordinary seasonal white nights of the northern latitudes. In London, people read newspapers outdoors at night without lamps. In Sweden and Scotland, photographers took landscape pictures at midnight without additional light. The same effect was observed in Germany and in Russia. The sky never became truly dark. It glowed with a cold, diffuse radiance. Where did this light come from? 100 years later, a theory appeared that seemed especially convincing.
In 2009, scientist Michael Kelly of Cornell University noticed an interesting coincidence. After the launch of the shuttle Endeavour in 2007, glowing clouds appeared in the upper atmosphere. They consisted of tiny ice crystals and were visible at night. It was very similar to what had been observed after Tunguska. The shuttle had released water vapor into the upper layers of the atmosphere. At great altitude and in extremely low temperatures, it turned into ice crystals. These began reflecting sunlight even after sunset. If the Tunguska body was cometary, that is, composed mainly of ice and dust, then as it broke apart, it could have released an enormous amount of water vapor into the atmosphere. This vapor would have risen to an altitude of tens of kilometers, frozen, and created a glowing screen over half a continent. And that is already an important clue. A stony or metallic asteroid would not have produced that amount of vapor, but an icy body would have. That is why the comet hypothesis gained a strong argument in its favor. It does not solve the mystery completely, but it does explain the silvery nights that so astonished Europe in the summer of 1908. And there is one more quiet trace of the catastrophe. It was not noticed right away. Only decades later, when scientists began studying tree rings.
The surviving trees in the blast area, including those very telegraph poles and the forest on the periphery, began growing faster than usual from about 1910 onward. Their rings became 2, 3, and sometimes even 4 times wider. This effect was observed not only near the epicenter. It was recorded far from it as well, at distances of more than 1,000 kilometers. That means the consequences affected an enormous territory. The simplest explanation seems entirely earthly. The explosion destroyed part of the forest. It opened up space, removed competition for light, and the ash and combustion products enriched the soil with nutrients. For the surviving trees, this became an unexpected boost to growth. The tree rings told more than researchers had expected. In the Tunguska region, they preserved traces of a sharp thermal shock in 1908 itself. Scientists saw deformed cells, saw signs of rapid heating, saw disruptions in the structure of the xylem. And this is important. Such marks were found not only near the zone of fallen trees, but also far from it, at distances of up to 1,500 kilometers. It turns out the impulse was not local. It seemed to pass through the atmosphere and cover a vast territory with a heat wave. The standard Airburst version generally allows for this, but it does not give a precise answer to another question. Why was the abnormal tree growth after the catastrophe so widespread? Why is the effect noticeable so far away?
There is still a blank spot here, and it is precisely from such details that Tunguska's special reputation is formed. It is not one mystery, but a whole chain of mysteries, where every answer gives rise to a new question. And here, another controversial trace appears. A few kilometers northwest of the presumed epicenter lies Lake Cheko. At first glance, it is not large, but its shape immediately raises suspicion. The lake bottom is unusually deep for its size. Its outline is elongated in the form of an ellipse, and that elongation points exactly toward the epicenter. For supporters of the impact version, this looked almost like a hint from nature. In 2007, researchers from the University of Bologna published a paper that sparked a loud dispute. According to their conclusions, Lake Cheko may have appeared precisely after the catastrophe of 1908. The authors pointed to the shape of the basin, to the great depth, to a magnetic anomaly in the center of the bottom. Their conclusion sounded bold. A large fragment of the Tunguska body could have fallen into the lake, having survived the airburst,
And if so, that fragment may still lie there under a layer of silt and bottom sediments. The version sounded striking, and so it quickly spread around the world. The Italian scientists insisted on new studies and proposed searching for the object on the bottom. But Russian specialists objected. They pointed to analyses of bottom sediments.
According to those data, the lake's age could be significantly greater. In addition, the trees on the shores turned out to be older than the catastrophe itself. That was a serious argument. If trees had been growing there earlier, then the body of water most likely already existed. Then the dispute became even more interesting. In 2017, data appeared according to which Lake Checo had existed at least a century before the explosion. It seemed the question was closed. But soon an important detail surfaced from old Evenki testimony. These are the local inhabitants whose accounts were collected in the 1920s and 1930s. They really did speak of a lake that had not existed before the catastrophe. Only they were probably not talking about Checo. Slightly farther south, there was a small lake, Suzdavala. It was this one, according to eyewitnesses, that had not existed before the explosion. A 2022 study published in the journal Frontiers in Earth Science proposed a simple explanation. During the catastrophe, a huge number of trees fell and blocked the channel of a stream. A temporary dammed lake formed. Later, the dam was washed out and the lake disappeared. It turns out the Evenki were not mistaken. They remembered the changes in the landscape accurately, but they were talking about a different place. And here the dispute comes alive again. Is Checo simply an old lake with an unusual shape, or is it still the trace of a falling fragment? There is still no single answer. The Italian group continues to believe that a remnant of the cosmic body may lie on the bottom. Russian researchers disagree, and even in 2026, the matter is not settled. By the way, if details like these interest you, subscribe to the channel. Here we examine not only the high-profile versions, but also what they rest on. But among all the hypotheses, one stands apart. More than 100 versions of the nature of the Tunguska event have accumulated. There were ideas about a comet, about a stony asteroid, about a release of natural gas, about ball lightning of incredible power, and even about a technological cause. The most famous of such hypotheses is connected with Nikola Tesla. On that same day, June 30, 1908, on the other side of the planet, on Long Island in New York State, Tesla was working with the Wardenclyffe Tower. This was his ambitious project for wireless transmission of energy over great distances. Tesla believed that electricity could be transmitted without wires through the Earth and the atmosphere. He claimed that by 1908, the installation was already functionally ready for serious tests. According to one later version, Tesla was supposedly conducting an experiment in long-distance energy transmission toward the Arctic. At that time, Robert Peary's expedition was there. Supporters of the hypothesis suggest that the impulse missed its target and struck Siberia. It sounds audacious, and it sounds almost like science fiction.
But that is precisely why the story has lived on for many decades. The problem is that there is no direct evidence. There are no documents confirming that Tesla really conducted such an experiment that morning. There are no reliable calculations showing that the tower could have produced power at such a level. Tesla himself never publicly connected himself with Tunguska. His records from that period have not survived in full, and some of the documents disappeared altogether. And that only fuels interest. There are, however, two facts that supporters of the version like to cite most often. In April 1908, Tesla wrote about the possibility of directly applying electrical waves without conventional weapons.
and in March 1907 he discussed transmitting energy to any designated point on the planet. What exactly he meant is hard to say. Tesla often spoke on the boundary between science and bold futurology. But after his financial collapse, the Wardenclyffe Tower was demolished by creditors, and the inventor himself destroyed some of his working papers so they would not be seized. This does not mean the version is true, but it cannot be completely buried for one reason. There is too little data. Science does not like emptiness, and where emptiness remains, legends are always born. And yet the main battle is not around Tesla, but around the very substance of the Tunguska body.
In 2013, 105 years after the catastrophe, a group of Russian geologists announced that they had found fragments of the object. Tiny particles with a total mass of only a few grams were extracted from peat deposits in a bog near the epicenter. Their chemical composition, according to the authors, was close to that of a stony chondrite-type asteroid. For many, this sounded like a long-awaited breakthrough. At last, a material trace had appeared. But the joy proved premature. Just a year later, another group of researchers challenged this interpretation. In their opinion, the particles could have had a terrestrial origin. Questions arose about the identification methods, about the cleanliness of the sampling, about the interpretation of the composition. The scientific publication prompted a response publication, and instead of a final solution, the world got another round of dispute. Today, the scientific consensus looks like this. Most likely, a stony asteroid about 50 to 80 meters in diameter exploded over Siberia. It entered the atmosphere at a speed of about 54,000 kilometers per hour. Then it broke apart and exploded at an altitude of 5 to 10 kilometers. The power of that explosion is estimated at between 10 and 30 megatons of TNT. That is enough to flatten forests across thousands of square kilometers and create a shockwave that was recorded by stations all over the world. And yet, even this version comes with caveats.
Most likely, in all probability, apparently, because the main piece of evidence is missing. There is no crater, no large fragment, no sample that can be placed on the table and identified without doubt as the very object itself, that very visitor from space that caused the largest airburst in documented human history. And this is where the true power of the Tunguska mystery lies. The event was colossal. The blast wave circled the planet twice. Forest was destroyed over an area comparable to a major metropolis. The sky over Europe glowed at night so brightly that people read newspapers without a lamp. In London, in St. Petersburg, in Scandinavia, people observed unusual silvery twilights and bright noctilucent clouds. The atmosphere filled with the finest dust and aerosols. They scattered light far beyond Siberia. It was an event of planetary scale, but it left behind no object that can be pointed to with confidence. That is why Tunguska is not just the greatest cosmic catastrophe of modern times. It is a catastrophe without a passport. We know its power. We know the date. We know the region. We know the consequences. But we still cannot definitively name the culprit. Every year on June 30th, International Asteroid Day is observed. The United Nations chose this date specifically in memory of Tunguska. And the meaning here is perfectly clear. Earth is not protected.
An object, about 60 meters across, if it enters at the right angle and happens to be over a densely populated area, is capable of destroying a major city in a matter of seconds. Such bodies are difficult to detect in advance. They are too small for early detection. They are too fast for late response, and the window for making a decision may prove frighteningly short. And perhaps the most disturbing thing in this story is not that we searched too little. We searched a great deal. Expeditions continued for decades. Scientists drilled into peat, studied resin, tree rings, magnetic anomalies, microparticles, old maps, and eyewitness accounts. But the object itself vanished, almost without a trace. It left behind a flattened forest. It left behind glowing nights over Europe. It left behind the debate over Lake Checo. It left behind hundreds of hypotheses. And it left behind one deeply human image. A peasant in Vanavara sits on his porch eating breakfast. The summer morning seems ordinary, and then the sky flares up. The earth shudders. The air strikes like a hammer. 117 years pass, and we are still trying to understand exactly what it was that tore across the Siberian taiga in that moment.